Chapter 2 Fractions. Equivalent fractions. Look at these strips. Some part of each strip has been shaded. Find out what is common thing among these. 1 by 2 is shaded. 2 by 4 is shaded. 3 by 6 is shaded. 4 by 8 is shaded. 5 by 10 is shaded. Clearly, all these strips have equal shaded portions, so the fractions represented by the shaded portions of the above strips are equal. Thus, 1 by 2 is equal to 2 by 4 is equal to 3 by 6 is equal to 4 by 8 is equal to 5 by 10. These are equivalent fractions. Fractions that represent the same portion are called equivalent fractions. Look at these bananas. We can say that there are 15 bananas or 3 bunches of 5 bananas each. 10 by 15 of these bananas are shaded, or 2 by 3 of the bunches of banana are shaded. 10 by 15 and 2 by 3 refer to the same number of bananas, so they are equivalent fractions. Finding out equivalent fractions. Let's learn how to find out a fraction equivalent to a given fraction. To get a fraction equivalent to a given fraction, we multiply or divide the numerator and denominator of a given fraction by the same non-zero number. Example 2. Find out 4 fractions equivalent to 3 by 5. Solution. The given fraction is 3 by 5. 3 by 5 is equal to 3 into 2 by 5 into 2 is equal to 3 into 3 by 5 into 3 is equal to 3 into 4 by 5 into 4 is equal to 3 into 5 by 5 into 5. Hence, 3 by 5 is equal to 6 by 10 is equal to 9 by 15 is equal to 12 by 20 is equal to 15 by 25. Example 3. Write 5 fractions equivalent to 2 by 7. Solution. The given fraction is 2 by 7. 2 by 7 is equal to 2 into 2 by 7 into 2 is equal to 2 into 3 by 7 into 3 is equal to 2 into 4 by 7 into 4 is equal to 2 into 5 by 7 into 5 is equal to 2 into 6 by 7 into 6. 2 by 7 is equal to 4 by 14 is equal to 6 by 21 is equal to 8 by 28 is equal to 10 by 35 is equal to 12 by 42. Finding out equivalent fraction with given numerator or denominator. Example 4. Write an equivalent fraction of 1 by 3 with numerator 5. Write an equivalent fraction of 3 by 4 with denominator 24. Solution. Let 1 by 3 is equal to 5 by. Here we have to find out the missing numeral. To get a 5 in the numerator, we multiply 1 by 5. Further, we also multiply the denominator by 5. 1 by 3 is equal to 1 into 5 by 3 into 5 is equal to 5 by 15. Hence, 1 by 3 and 5 by 15 are equivalent fractions. Let 3 by 4 is equal to by 24. Here, we have to find out the missing numeral. In order to get 24 in the denominator, we multiply 4 by 6. Further, we also multiply the numerator by 6. 3 by 4 is equal to 3 into 6 by 4 into 6 is equal to 18 by 24. Hence, 3 by 4 and 18 by 24 are equivalent fractions. Example 5. Find out an equivalent fraction of 45 by 75 with numerator 3. Write an equivalent fraction of 25 by 35 with denominator 7. Solution. Let 45 by 75 is equal to 3 by. In order to get 3 in the numerator, we divide 45 by 15. We also divide the denominator by 15. 45 by 75 is equal to 45 divided by 15 by 75 divided by 15 is equal to 3 by 5. Hence, 45 by 75 and 3 by 5 are equivalent fractions. Let 25 by 35 is equal to by 7. To get 7 in the denominator, divide 35 by 5. Also divide by 25 by 5. 25 by 35 is equal to 25 divided by 5 by 35 divided by 5 is equal to 5 by 7. Hence, 25 by 35 and 5 by 7 are equivalent fractions. To test whether two given fractions are equivalent or not, let's consider two equivalent fractions 2 by 3 and 6 by 9. Now multiply the numerator of the first fraction by the denominator of the second fraction and then multiply the denominator of the first fraction by the numerator of the second fraction. 2 by 3, 6 by 9. 2, 9, 3, 6. 2 into 9 is equal to 18. 3 into 6 is equal to 18. We find that the two cross products are equal. So, we may conclude that two fractions are equivalent if the cross products are equal. Numerator of first into denominator of second is equal to denominator of first into numerator of second. We shall understand this concept clearly from following examples. Example 6. Are the following fractions equivalent? 3 by 4 and 21 by 28. 7 by 9 and 70 by 72. Solution: cross multiplying, we get 3 by 4, 21 by 28, 3, 28, 4, 21. Here 3 into 28 is equal to 84 and 4 into 21 is equal to 84. The cross products are equal. Hence, 3 by 4 and 21 by 28 are equivalent fractions. Cross multiplying, we get 7 by 9, 70 by 72, 7, 72, 9, 70. Here 7 into 72 is equal to 504 and 9 into 70 is equal to 630. Therefore, 7 into 72 is not equal to 9 into 70. That is, the two cross products are not equal. Hence, 7 by 9 and 70 by 72 are not equivalent fractions. Like fractions. One by 5, 2 by 5, 3 by 5, 4 by 5. The denominator in all the above fractions is 5. Such fractions are called like fraction. Fractions having the same numeral as denominator are called like fractions. For example, 3 by 8, 1 by 8, 5 by 8, 6 by 8, 4 by 8, etc. are all like fractions. Unlike fractions. Two by 7, 3 by 5, 1 by 4, 5 by 6. The denominators in all the above fractions are different. Such fractions are called unlike fractions. Fractions having different denominators are called unlike fractions. For example, 3 by 4, 2 by 9, 3 by 7, 2 by 5, etc. are all unlike fractions. Comparing fractions. If two fractions have same denominator, the fraction having a greater numerator is the greater fraction. 5 by 12, 3 by 12. Therefore, 5 by 12 is greater than 3 by 12 as 5 is greater than 3. Thus we conclude that out of the two fractions with the same denominator, the one having smaller numerator is smaller than the other. If we are given a set of fractions with the same denominator, then we arrange them in the ascending or descending order according to the ascending or descending order of their numerators. Example 7. Which is greater, 6 by 7 or 3 by 7? Solution. The given fractions have the same denominator, so the one having greater numerator is greater than the other. Since 6 is greater than 3, we have 6 by 7 is greater than 3 by 7. Hence, 6 by 7 is greater than 3 by 7. Example 8. Which is smaller, 5 by 11 or 7 by 11? Solution. The given fractions have the same denominator, so the one having smaller numerator is smaller. Since 5 is less than 7, we have 5 by 11 less than 7 by 11. So 5 by 11 is smaller than 7 by 11. Example 9. Arrange the following fractions in the ascending order. 7 by 9, 3 by 9, 5 by 9, 2 by 9, 8 by 9. Solution. The given fractions have the same denominator. We have learned the fractions with smaller numerator is smaller. As 2 is less than 3, is less than 5, is less than 7 and is less than 8. We have 2 by 9 is less than 3 by 9 is less than 5 by 9 is less than 7 by 9 is less than 8 by 9. Hence, the given fractions in the ascending order are 2 by 9, 3 by 9, 5 by 9, 7 by 9, 8 by 9. Example 10. Arrange the following fractions in descending order. 4 by 11, 7 by 11, 5 by 11, 10 by 11, 2 by 11. Solution. The given fractions have the same denominator. The fractions with greater numerator is greater. As 10 is greater than 7, is greater than 5, is greater than 4, is greater than 2. We have 10 by 11 is greater than 7 by 11 is greater than 5 by 11 is greater than 4 by 11 is greater than 2 by 11. Hence, the given fractions in descending order are 10 by 11, 7 by 11, 5 by 11, 4 by 11, 2 by 11. Comparing unlike fractions with the same numerator. If two unlike fractions have the same numerator, the fraction with the smaller denominator is the greater fraction. Therefore, 3 by 4 is greater than 3 by 5, as 4 is less than 5. 3 by 4, 3 by 5. So, if we are given a set of fractions with the same numerator, then we arrange them in the ascending or descending order according to the descending or ascending order of their denominators. Example 12. Arrange the following fractions in the ascending order. Solution. 5 by 14, 5 by 7, 5 by 8, 5 by 13, 5 by 10. The given fractions have the same numerator. The fraction with larger denominator is smaller than the others. As 14 is greater than 13, is greater than 10, is greater than 8, is greater than 7, we have 5 by 14 is less than 5 by 13, is less than 5 by 10, is less than 5 by 8, is less than 5 by 7. Hence, given fractions in ascending order are 5 by 14, 5 by 13, 5 by 10, 5 by 8, 5 by 7. Example 13. Arrange the following fractions in the descending order. 4 by 6, 4 by 11, 4 by 8, 4 by 5, 4 by 13. Solution. The given fractions have the same numerator. The fraction with smaller denominator is greater than the other. 5 is less than 6, is less than 8, is less than 11, is less than 13. We have 4 by 5 is greater than 4 by 6 is greater than 4 by 8 is greater than 4 by 11 is greater than 4 by 13. Hence, the descending order of the given fractions are 4 by 5, 4 by 6, 4 by 8, 4 by 11, 4 by 13. Addition of like fractions. Amit and Sumit ordered for a pizza in a restaurant. The pizza, when served, was divided into 8 pieces. Amit ate 2 pieces. This means he ate 2 by 8 of the pizza. Sumit ate 3 pieces. This means he ate 3 by 8 of the pizza. What fraction of the whole pizza did they eat altogether? They ate 2 by 8 plus 3 by 8 is equal to 2 plus 3 by 8 is equal to 5 by 8 of the whole. So when we add like fractions, we add the numerators. We write the sum over the same denominator. Subtraction of like fractions. Let's consider the above example once again. Amit ate 2 by 8 of the pizza. Sumit ate 3 by 8 of the pizza. Who ate more? As 3 by 8 is a large number, we can say that Sumit ate more. How much more did Sumit eat than Amit? Here, we need to subtract Amit's part from Sumit's part. That is, 3 by 8 minus 2 by 8 is equal to 3 minus 2 by 8 is equal to 1 by 8. From the picture, you can tell that Sumit ate 1 more piece than Amit ate of the 8 pieces of the pizza. So, when we subtract like fractions, we subtract the numerators. We write the differences over the same denominator. Let's understand the concepts with the help of following examples. Example 14. Add 3 by 9 and 4 by 9. Solution. 3 by 9 plus 4 by 9 is equal to 3 plus 4 by 9 is equal to 7 by 9. Example 15. Add 3 by 5 and 2 by 5. Solution. 3 by 5 plus 2 by 5. 3 plus 2 by 5 is equal to 5 by 5 is equal to 1. Example 16. Subtract 4 by 9 from 7 by 9. Solution. 7 by 9 minus 4 by 9 is equal to 7 minus 4 by 9 is equal to 3 by 9 is equal to 1 by 3. Example 7. Subtract 4 by 7 from 4 by 7. Solution. 4 by 7 minus 4 by 7. 4 minus 4 by 7 is equal to 0 by 7 is equal to 0. Example 18. Anuja ate 3 by 10 part of the cake in the morning and 4 by 10 part of the same cake in the evening. How many parts did she eat of the whole cake? Solution. The part of the cake Anuja ate in the morning is equal to 3 by 10. The part of the cake she ate in the evening is equal to 4 by 10. The part of the cake she ate altogether is equal to 3 by 10 plus 4 by 10 is equal to 7 by 10. Example 19. Mr. Ganesh drove 7 by 9 of the distance and Mrs. Ganesh drove 2 by 9 of the distance. Who drove more and by how much? Solution. The distance Mr. Ganesh drove is equal to 7 by 9. The distance Mrs. Ganesh drove is equal to 2 by 9. Difference in distance they drove is equal to 7 by 9 minus 2 by 9 is equal to 7 minus 2 by 9 is equal to 5 by 9. Proper and improper fractions. Proper fraction. Proper fraction is a part of the whole. Till now, we have studied proper fractions. 3 by 5, 4 by 7, 9 by 13, etc. are all proper fractions. Fraction which has the numerator less than the denominator is a proper fraction. Improper fraction. What is an improper fraction? Let's understand it with the help of the following example. There are 5 family members in Gopu's family. Each person brings half a glass of milk. To show 5 halves, we should write 5 by 2, number of parts consumed by number of equal parts in each glass. Here, 5 by 2 is an improper fraction. 7 by 2, 9 by 5, 11 by 4, etc. are some other examples of improper fractions. A fraction which has the numerator greater than or equal to the denominator is called improper fraction. Improper fractions can also be expressed as mixed numbers. Mrs. Gopu has baked 2 cakes for her family. She cuts each cake into 2 parts. Her family eats 3 pieces of cakes or 3 halves. We can say that the family has eaten 3 by 2 or 1 by 2 cakes.